The two-sum problem asks, given an array of integers and a target value, does there exist a pair of numbers in the array whose sum equals the target? Let's solve this using three approaches, starting from the most obvious one and ending with the most efficient one. Our array is 0, -1, 2, -3, 1. Our target is -2. Approach 1, brute force. The simplest idea is to check every possible pair of elements. We use two nested loops. The outer loop fixes the first element, and the inner loop checks it against every element that comes after it. We compare each pair's sum with the target. If we find a match, we stop and return true. This approach checks every single pair, giving us a time complexity of O of n squared, with constant extra space. It works, but it repeats a lot of unnecessary work. Can we do better? Approach 2, two-pointer technique. If we sort the array first, we can use 2 pointers, one starting from the left moving forward, and one from the right moving backward. We add the values at both pointers. If the sum equals the target, we are done. If the sum is smaller than the target, we move the left pointer forward to increase our total. If the sum is larger than the target, we move the right pointer backward to decrease our total. Because the array is sorted, this lets us eliminate one element every step, giving us O of n log n time, mainly due to sorting and constant extra space. This is much faster than brute force, but sorting still costs us time, and this approach only works efficiently because we sorted the array first. Approach 3, hash set. This is the optimal solution. Instead of comparing pairs directly, we walk through the array once and use a hash set to remember numbers we've already seen. For each number, we calculate its complement, target minus the current number. If that complement already exists in our set, we've found our pair immediately. If not, we add the current number to the set and move on. Now let's look at how this logic matches up directly with code execution flow. We loop through each number, calculating its complement. If the complement is already present inside our hash set, we have found a valid pair. Otherwise, we store the current number and continue scanning the array. To summarize, brute force is O of n squared, sorting with 2 pointers is O of n log n, and the hash set approach is O of n, making it the best solution for the two-sum problem.